Hello and welcome to our QTest demonstration. Over the next 10 minutes I'm going to be showing you how to create advanced load and performance tests while saving time and effort with QTest. We're going to be creating valuable reports and capturing user transactions, generating real user load and diagnosing problems. Let's get started. What's our goal? We want our website or web application to be the best it can be. One of the biggest issues for websites is that of speed and performance. How do we know it's going to cope when we release it to its audience? We don't, so we need to test it. There are many levels to web applications: web servers, application servers, databases and software, and the only way to get a real insight into a complex system like this is to test it end to end with real or simulated users, lots of them. We can do this by monitoring back-end infrastructure and generating real user load with QTest in as little as one desktop PC. As performance testing is often one of the last parts of a project and sometimes even an afterthought, one thing we don't often have is a lot of time to do our testing. We need software that's quick to set up, easy to use, fast to deliver and most importantly accurate and concise in its results. When compared to other solutions, we know that while QTest is a sophisticated performance testing tool, it can still deliver time savings of 30 to 45%. In this demonstration I'm going to show you step by step how we do that. The first thing we need to do is record a real user transaction. To do that I'm going to use Quotium Center. It's a convenient place where scripts are recorded, load tests are designed, monitoring is done and reports are stored. Right now I'm going to record a new script against a bookstore application, and in this case the transaction I'm going to record is the transaction of buying a book. Double clicking the script launches the Quotium script editor, which has the record button. Clicking it launches Internet Explorer. We can use any other browser to record, but in this case we're going to use IE. I'm going to navigate to my website. QTest is recording all the HTTP that we send down the line and also the user wait time. So as a user would do, I'm logging into the application. Nothing extra here, just using Explorer as a normal user would do. I'm going to buy this book, I've added it to my cart, go to the shopping cart and proceed to the checkout. There we go, the order was taken into account and now I'm going to log out. That's all I want to do for this script, so I hit the stop button and we can see that the script's been recorded. Don't worry that it is a script, we're not going to have to do any programming, as QTest has plenty of wizards and helpers to edit the script for us, as we'll see as the demo progresses. Now, as this is a Java website, there's a session ID. A session ID is something that the web server uses to identify users. We can see this here, and that means this script won't work when we try and replay it with lots of users. Using another tool you may have to create some code to deal with this, but luckily in QTest we've got something to deal with the J2EE web application, and it's called a model. We apply that model and we can see that QTest has now automatically parameterized the session ID. The script's now ready to play back, and to make sure it works we're going to look at the replay window now. So the customer's now logged in. We go to the checkout and it's done. You may notice that the script was played back quite quickly, and that's because we're playing back at 10% of capture wait time. And that speed is one of the many things that can be reconfigured when we design the load test. It looks like the script played back correctly, but just to make double sure, we can look at the recorded and replayed differences wizard. It looks like the script was correctly recorded and replayed, as we can't see any differences in the windows. On the left we have what was captured, on the right we have what was replayed. We can now use this script to simulate more than one user, but to make it as realistic as possible what we should do is parameterize the username and password. Again, this is something that can be automated as a model, but in this case I'm going to show you how we do it without doing any coding. So at the point in the script where I logged in, I click the request details button and then look at what the client sent to the server, and I can see my username and password in there. I'm going to change the username to be a variable value, which I'm now going to create. Giving the variable a name, I want to populate it with some values from the database. QTest has a really handy feature to extract data from a database, and as load testing can be extremely data hungry, test data is something that you're going to need a lot of, and traditionally can be quite a difficult thing to come by. All I'm going to do is take all of the client login details and extract them. And here we have it. I'm going to have QTest create these into a file, which I'm going to call user test data. When the script replays I want it to select a random value. So that's my variable created. I just select it and apply the changes. Now the test is ready to run and I haven't had to do any coding. So I'm going to save my script and exit the script editor. Now we've quickly and easily created a realistic transaction, we're ready to generate real user load using QTest. The next thing we need to do is design our scenario, then we can execute the simulation of real users. Recorded scripts can now be used to accurately simulate a production scenario. Scripts will be fed data, executed, controlled and measured as virtual users by Quotium Center. While realistic load is sent to the system under test, Quotium's broad monitoring capability will keep a record of the health of the back-end systems along with response times, transaction rates, concurrent users and so on. This data is used in the reporting and diagnostics phase. To start generating load, the first thing we need to do is create a new job. And we do this back in Quotium Center where we started. Then all I do is drop in the scripts that we created, and also some that I've created previously. I'm going to generate two different types of user here. One of them is going to be a customer, which is going to execute the script that I created just earlier. Another one is going to be an administrator, which will allow a virtual user to go in and change the address of the customer, simulating a different type of load. My customer, I want them to browse and then buy a book, so I'm going to switch the transactions around. And actually I want 5 browsers through the website for every book that I buy. I want to run 100 users like that, and I want to ramp them up in batches of 10 every 2 minutes. This will allow me to identify any breakpoints using this stepped approach. I want 5 administrator users, and I'm going to ramp those up in a linear fashion over 20 minutes. Load is going to be generated locally on this machine. I don't want to do any IP spoofing. We don't have a load balancer in this case. Which the script is ready to run. And we're almost ready to run. The difference is I just want to make these users run manually until I hit the stop button instead of after a fixed time or a fixed amount of iterations. If I run this job now, I'll get some valuable information back, like response times, number of virtual users attained, hit rates for example. I also want to get the health of the back-end systems back as well though, so I'm going to look at my application server, my database, and the operating system, and everything's running on this machine, so we're just monitoring the local machine. I'm going to give these some meaningful names. Counters incidentally are very easy to set up, and it's as simple as that. In some cases there's even less to do. So that's it, I'm ready to run. Of course that last section was fast forwarded. So this next part is going to look at analysis and diagnostics, which will help us tune, modify or correct our system. Everything that we saw during the time when we were recording the test is now saved across into our results tab, and all the graphs that I can create in here I could also create in the runtime tab. I have to wait till the end of the test for us to generate the anomaly list, and I've created an anomaly list just by adding together the JBoss anomaly profile, the Windows anomaly profile, the MySQL anomaly profile and the HTTP anomaly profile. I've then saved it as Quotium Bookstore. To create that list now, it's a way I can see that there are several anomalies. Just before we look at those, let's just take a look at the global HTTP view, and the first thing that I can see is that while the users continue to ramp up past 7 minutes, we see that the HTTP requests per second and also the hits kind of maxed out around about just after 7 minutes. So I know that there's something went wrong. And just to confirm that, QTest is telling me this as well. And I'll prove that by just looking at the anomaly profiles. We're looking at latency, and it tells me the GET request in this case that was causing it, and we see that we start to get the latency problems after around about 7 minutes, which is where we have about 50 or 60 started users. So that tells us there is a problem, which is great, but we probably need some more information about why there's a problem. There's lots of information here about the Java virtual machine and the JBoss application server, and also some more information about the MySQL backend database. It looks like at around about the time where the bottleneck occurred, we seem to be getting an awful lot of table locks. We've got one other anomaly here, which relates to the number of requests to read the next row in the data field per second is greater than 10. So what does that mean? Well, actually we can't see so well because of this resolution, but if I drop this up, then we have some information which helps us understand why this might be. And actually this anomaly started quite early on in the test, and it's saying that the problem that we have here will occur if we're doing lots of table scans. Generally it suggests that the tables aren't properly indexed, or that the queries aren't written to take advantage of the indexes that we have. So straight away we know that there's a problem, and it relates to the backend database, which gives us a place to start. If I want to build a graph, For example, to compare the CPU utilization against the response times, then I can do that but just by dragging and dropping and creating graphs. So I've added my CPU, I want that to be on the right axis of the graph, and I want to put on some response time timers, some timer values over time. I'll just drop those on. So there we go, we can see that CPU is also affected by the test, and this is the relationship between CPU and the response time from the users. I can of course save that graph to Excel if I want, or into a Word document, which leads us on to the next section. So now we've looked at our results, let's see how we can quickly export them into a configurable Word document. All it takes is a right click on the set of results that we're interested in. QTest then asks me which report template I want to use, because of course this report is completely configurable, and then a file name to output it to. I then hit the generate button and QTest generates the report for me. The report's now generated and saved in a Word document, and any graphs specified to be in the template will then appear in the report. If you'd like to see how to specify a template, please see the other section in this demo about creating QTest report templates. And that's the end of the demo, so thanks very much for listening. You can get hold of us on www.quotium.com or on any of the numbers you can see on the lower left.